Welcome back, guys. Yeah, let's just get started with where we left off yesterday. Yesterday, we were trying to debug this recursion issue. Yeah, it's not even a X4 file system bug. It's just actual implementation bug where we have to actually recursively parse directories, and it's just an implementation bug that I'm not able to fucking figure out, so I'll be working on that today to see what exactly that I'm missing and fix that and maybe get it working. So overall, last week we managed to get the entire directory parsing working, as in we are able to parse things recursively and we are able to print things. We are just not able to store things because to store it, our recursion should have a proper index, and that index seems to be completely off. And every time we are somewhere in the recursion, we are just overwriting things, so the final stored output is completely wrong. This is what we were trying to debug yesterday, but no luck. Yeah, so let's just start it today and see if we can get it working. But overall, we're still working on our own kernel. We have lots of subsystems done. Hi, we have lots of subsystems done. Oh, thank you. Welcome, welcome. We managed to finish the MMU layer, scheduler, a little bit of user and kernel separation. And currently we also worked on the block layer, which is done. We are working on the front end for the VFS layer so that we can actually load user processes from a file system, and that was the initial whole idea of getting here. Yeah, so let's just get started with our X4 debugging. Yes, I'm working as senior security engineer, and I mostly just stream about kernel development. And because I have, like in general, I used to get a lot of security issues related to kernel, and whenever I read stuff around it, I feel like I'm completely lost because I know what it is affecting and what's the effect of, what's the deal with those CVs, but I don't really understand what's going on internally, how exactly a bug is able to get certain privileges. So that's why I started this entire flow of understanding how kernels work internally so that I can maybe improve my own understanding of developing kernel exploits. But so instead of just going through any theory, I'm writing my own kernels so I can actually understand how things work internally. And so far it has been going well. I have almost done with lots of subsystems and currently it's working, and we are even able to parse the entire file system. Yeah, hi. Yeah, so let's go back to our bug that we were trying to figure out yesterday. It was just this particular function, which is the recursive directory parsing, and here we are supposed to get an raw bytes, parse that as directory entry. Yes, that was just for fun because I wanted to do something in masters and I had no idea. I mean, I was pretty sure about my security skills, and in general, machine learning is also not that interesting for me. So I thought maybe we can try electronics and see what's going even deep down in IC level. And that particular subject was really hard because I had to learn a lot of physics to actually clear that paper. It was just fucking annoying, but yeah, I didn't. At least now I know what exactly those 5 nanometer chips are the 4 nanometer chips. So what exactly that 4 nm? I would say the entire degree was just about that one line. Other than that, I didn't learn anything much there, but yeah, it was fun. It was fun 1 year. Okay, let's see. Let's see. Yeah, we are inside this. We have the raw bytes, and we are supposed to parse them, and we get the actual entries. And here we are actually able to parse it, and we are even able to print it. So the issue here is that we are supposed to save that entry, because uh, printing is just UART is printing it directly, so it's not saving anything, but we actually have to save that. Only then we can use it later. So we have this directory results with this index, and this index is the one that is fucking with us, and it is completely wrong throughout the entire recursion loop. So we just keep on overwriting the same entries again and again. Yeah, so we have to figure out that. Yesterday we tried, it did not go well. We only made it worse, I believe, because this is the saved output. Because if we just directly print within the loop, we are able to see the entire output properly. We have all the directories and the internal directories. At the moment I save it, I need the actual index, and somehow I'm not able to properly send those indices within the recursion, so it's just ending up overriding the same entries. So I was just debugging it for like 1 hour yesterday, and it did not go well. So yeah, so let's go, and this is what the picture that we want to implement. I believe we have implemented it like that. So let's assume that we have one directory that is A, and it has two internal directories, which is X and Y, and we have B and C that are already in the top. So our recursion should go to A, and then find that it has two more directories internally, and then go inside X and Y and see if there's no either. You can just verify if there's any directories or not. And it has to store in every level, it has to store the actual output. So in that case, in index 1 we should have A, and in index 2 we should have X, and index 3 we should have Y, and then the recursion would go back to A, and then it will go to the next directory, that would be B. So the index 4 should have B, and index 5 should have C. That's the whole idea, and this is what we are not able to get it working. I am pretty sure it's because I'm not able to get the running sum, and these are the stuff that we skip in the day algorithms, and I have no clue. And it's not even related to our X4, it's just simply we didn't write the recursion properly. So yeah, let's see. So this is the image I want to get into my mind. So we are in the initial recursion phase, that we have the root node and the current index is 0, and we append A, that is the initial node, and then we can increment the counter to +1, and then we explore the current node. So we have another recursive function. So here we start by passing current index as 1, and within that function we do the same thing, that is to append the current index to the slots, increment the index, and recursively call that, I believe, or at least the code looks almost the same. So I have this recursive directory parsing, and this initial for loop does not matter. It's just there for to group the physical blocks, because recursive directory parsing will actually get an block result. So block result means a single directory can be represented as multiple blocks, because in the actual physical storage or in our external device, a single directory could be stored in multiple physical blocks. So every physical blocks will actually have a block result. So that's why we have this particular for loop. So we go through every physical blocks and get the entire output. So we read it and then we parse that raw bytes that we read from the physical block as directory entries, and it's working fine. We are able to print everything, so it's definitely working, and we have the directory entries as directory struct. Now that we have the actual directory, that means we can actually get into the directories. That's why we have the this loop. So if forget about this number, it's just static to debug things as of now. But let's say we have two directories, there is bin and etc. So we go to bin first and then we store bin as a result. So we store it in the current index. So current index starts with 0. So in the current index we update temp. Temp is just the current node, current directory that we parse. And then we increment it, and then we explore that directory again. So this is the entire recursion, and I feel like it should have worked, but it just does not seem to be working at all. So yeah, so we have to figure out that. And it just throws lots of dump which we are not going to read. So we have to visualize this on our own. If not, it will be hard to fix it. I need one idea. So I guess my recursive directory parsing. So let's just shit. Why am I not able to copy it? Activate it. Looks just fine. Only my index is not updated properly, so my entire outputs are getting overwritten. So how are we supposed to visualize that indexing alone? Yeah, let's just see if we can first of all figure it out, because we are able to print everything. So for sure, the only thing that we are missing is this index. We just have to properly increment it and not. Also, the another operation that feels wrong is this current length plus the current inside. Yesterday we tried a lot of stuff around this because we changed it into two different counters. One is for the external loop, which is current length, and then we added a new internal counter which is called current inside. The naming is so fucking dumb, but still, I was hoping it would work, but it did not work. So yeah, let's see. Okay, yeah, that was my whole idea, because when we are actually inside a recursion, we should only have a running length, because that length needs to be returned to the parent, and the parent has to increment it to the main current length. That was my whole fucking idea. Okay, it's saying something, but I don't understand what that means, because it just says that we are reinitializing current length. But yeah, we are reinitializing current inside with current length, because in the first attempt our current length will be 0, so our internal current inside should also be 0. And let's say we are in the second directory. At that point we are supposed to take the previous current length, because we are somewhere down the line and we should know what's the last index that was used. That's why I took current length as current inside, and from there I'm incrementing current inside, and then I'll forward that current inside to the recursive directory passing, because at this point the same entire process is gonna repeat itself, and this is gonna just give me back a length, and I have to add that length back to my current length. At least that's how I'm picturing it, but for sure it's wrong, because it's not working, and it is also saying that it's wrong, but I'm still not able to visualize it. So unless I visualize it, I will not be able to understand it. And index into shared storage has two properties, value and lifetime. What the fuck that means? Function frame, we have the directory count. First by value, yes, because that's fine, because I'm returning a value, not a reference. So in the end, we should have the actual reference. It is not a value. That was the whole point. Read directory, and we write the results here. If this current inside actually got the value from the previous iteration, then this should work. So maybe the issue here is that the proper values are not propagated. I don't know, let's see. So Casa lives in a narrower scope than the loop that uses it. That's the whole bug. Okay. Okay, so let's say the current length is 0 and the directory has 5 entries, A, B, C, D, E. Okay. We start from 0. We enter right. Thank you. Thank you, YouTube. We write it to directory 0, and the current length still stays as 0. And we have to expand this, so the formatting will be better. Directory count, current length, and we have the initial iteration per block. We read the directory, and we have the iteration per directory entry. Inside that we have the current inside, but then this current inside is assigned with current length, and for every iteration we are doing that. Okay, maybe that's the issue. The second time I start, I should not have the current length. Yeah, because if there's 2 entries, and in the first entry if I have already used and updated the current length, yeah, let's say I have updated it, and the next time I come back here, I should be able to use it again. That's not an issue. Current length, current inside, slot return is 0 equal to A. And then we have K is equal to 1. Here again, we just write to directory entry 0. Right reads current inside, and then we bump the current inside. Next K reads current inside, but it's a new value. Loop, ball entry, loop exit. I didn't understand any fucking thing. I guess instead of fixing this, I'm just going to implement a queue-based version so that it will go iteratively instead of recursively. Slot index, and where is the slot? I don't know. I don't see any slots here. It's fucking lines in here. So we have the current insides, and that is just current length. And I believe this is what it is referring to, because every time I'm just reinitializing current inside with current length, which is not good. That is what it is trying to say. So if that's the case, then what exactly should I have that? But the whole point of having is that I need a running sum. So let's just say that we have only current length. We start with current length as 0, and let's remove this entirely. Now we only have current length. Now we have the current length, and we increment the current length. And in case there's nothing to explore here, we are supposed to do nothing because it's already incremented. No, we don't need this because there's no such thing. No, we just remove this. Okay, now we recursively call directory parsing, and it's going to start with current length. Current length, and it is going to give me an output which is the actual output from that recursive version. And if that is actually more than 0, that means I can increment current length with that. we don't even need this. We could just say current length equal to, because if it's 0, it wouldn't matter anyway. Let's just remove this. We'll remove that, and let's just also remove this. See what happens. I guess this was my initial implementation. And I don't need this anymore. Let's just remove this entire thing. So let's just simplify it. So we get into it, we start with current length as 0, and then we go into our first directory and we update that, and then we explore it, and whatever we got from that exploration, we add it to current length and we return it in the end. I don't know, let's try it. Just feels, I mean, like, this was my initial implementation and it didn't work. That's why I tried something else. So here we only passed 8 directories and we have something like this. So let's try to see those logs and see what exactly have we printed. We need the logs for call recursive. Okay, so this is the initial one. So we have current length as 1 because the initial directory is already added. And then we go into the recursive loop, and that loop has 2 directories. So it has 2 directories. So what happens after that? Wait, it has 2 directories. So the current length is 1, and then we have 2. How? Right. That's the thing. This is actually supposed to return me 2 because it found 2 directories within it, which is dot and dot dot, which is current directory and the previous directory. So this should have given me 2, but why is it just giving me 1? Let's remove this recursion entirely. So let's just print it without any recursion. Oh, I was thinking we would be debugging stuff around kernel, but I never thought we would be debugging recursion. So without any recursion, we only have 3 directories. Why is that? That's not correct. Wait, where is it called? We call it here, and go inside, and we parse directory. Maybe I have some sort of condition to only parse 3. Looks like I have a condition to only parse 10. Even then, I should have at least gotten 10 nodes here. this maybe we might have to come back and debug this one, because even here we are using index to store things. Okay, whatever. And then we have recursive direct entry, and we increment current length, and we explore maybe here. Okay, let's go here. Yeah, we don't have any specific restrictions. We are almost pretty much dynamic. Pass extend block, and we have a depth of 2. Maybe that's the issue. Wait, what is an extend? Extend is just yeah, we parse iblock as extends, and extends can have multiple depths, and I'm pretty sure we will not reach depth 2 here, because that's how I remember it, because in this case either it will be 0 or 1. Most probably will never reach extent depth 3, so this is not the issue. Okay, so leave that. So maybe we can increase this to, let's say, 256. Yeah, I don't see anything else. Let's rerun it. Bash belts. Kill it. Okay, it did not change anything, and it has only reduced the total parsed directories to just 3. Let's test it down. Okay, let's remove that. Pass nodes is less than 1. And we're pretty sure. Okay, we have a KS5. Okay, maybe this is the element. Let's try 24 here. And I have already updated the overall possible directories to 256, I think. Yeah, I should be able to store up to 256. Let's get that. Let's run it. And okay, it is working. Now we have parsed 8 directories. We have parsed 8 directories, and it has 368 indices. Now let's see if I re-enable this. Let's see what happens. Okay, it works because I have media and then I have four more. Okay, I guess it is working. But then there should be a lot more than that, right? For per node, we are parsing up to 24 directories per directory, because if we get into a directory, that directory can have up to 24 internal directories. That is this limitation. Hi. Okay, so that is fine. So let me just see the logs once more. Okay, so this is the initial log. We have the entire root raw dump, and then we parse it into actual directory entries, and we are able to print every directory separately. So once this initial iteration is done, the final directory entry is media. Now we go into the first directory that we got in this, that is this last and found. So inode is 11. So we are exploring inode 11, and then we got two directories within it, which is just dot and dot dot, because it does not have anything else. Okay, so the next node we are exploring is 13, and yeah, before that, because we explored two nodes, our current recursive length is 3. And then we try to explore a new node, and that node has this many raw things, and we print each and every directory, and then we should have actually saved it. If that actually happened, then we should have more than just 8 directories. Because as you can see, the current directory count is actually 11 somewhere here. So we still have something going wrong. And as you can see, this directory seems to be having lots of data. And by the end of this, okay, somewhere down here, the current directory count got resetted. Okay, we can do one more thing. Instead of using indexing based approach, let's just use a global variable. Yeah, which is not good, but let's just test it. So let's put static event 64T current length. This is not the actual implementation. This should not use anything like this. It's just going to be wrong. But I'm just going to use this to see if things are working. So in that way, I'll always just use the global variable and I'll increment it. And the actual recursions should also do the same thing. Yes, the input will not be considered. Let's just remove that too. So we'll remove it here. And it will always just use the previous one. And I don't want to increment it either because it does not matter. And we can just print it. No, it does not matter because we'll always have a global current length. Okay, what is this? Okay, we don't want to pass this here either because it's always assigned to 0. Maybe I could just assign a Camelot UN64, but then I'll have to again pass things. It's gonna be annoying. Okay, as you can see, this time we got better results. We have 24 parsed directories. This is still not correct. Still something is wrong. Now let's just get all count current directory count. This is the message that we want to track. Let's see. Let's just go here. Enter. Looks like it did work because this is the initial directories that are printed here. And then, oh shit. And then we go to the initial directory and then go to the next directory. Here we have multiple actual directories. So we add them. So every time the current directory is increasing, but shouldn't, no, yeah, it's correct because only when we are actually in this loop, we are incrementing it. Okay, so that is fine. And then we are here. Here we have lots of stuff. Then the actual issue is this. Let's just put this. This shouldn't be an issue because here I don't think a single directory has more than 24 entries and we can only store overall 256 entries. So this should not be an issue. Maybe the issue is that my directory of K is not working. I'm trying to access it like this to confirm if that entry even exists. And for every extent, we are parsing up to 10 nodes. That also means that it can only have 10 entries. Yeah. That means I should also increase this here. Let's say 48. Okay, now I'm fucking stuck somewhere. Okay, I guess now we parse more than what we can store possibly. Let's just say 24. Let's just say 24 that way. Yeah, 24. Because we can only store up to 256. That's our maximum. What? Okay. Of it, then we'll just increase that amount. And let's assume that it will work. As our initial entry, initial call, let's just say 250 high. Let's just say 512 entry and put 512 here. And let's just put 512 here. Now if we do the same thing, it's like we are reading more entries every time. What exactly is the error? Probably this relative index is completely wrong. Hi. Nope. This is getting out of hand. Ah, fuck it. We were able to pass it. Because every entry, only because we were there and we were able to actually read it, we are able to print it. But my fucking indexing is just not working. Oh, fuck it. Let's just reduce that to something less. Let's just say 2 nodes. No, let's say 4 nodes. Let's see if we can actually go through all those 4 nodes through the logs. Maybe that way we can figure out. Exactly. Let's just reduce the numbers so we can actually go through the entire logs one by one. I guess that's my only solution. Let's just put 4 here. So we are gonna parse 4 entries here and 4 directory extents internally, and we have space up to 512. So now if we run it, we should be able to see it. Okay, now we have the initial raw bytes. We have 1, 2, we only have 2. Okay, these 2 will also be considered as a directory. So this is 1 directory, this is 2. So we have 4 up to 4 nodes, and then we will stop there because we have a limit. And now let's see the actual recursion logs for this. So the current directory is initially 0. So at this point we would have incremented it, and then we are exploring 11. Okay, so let's say we explored it here. Currently we are here, so we have the recursive length, current length, which is just 1, and we do the parsing for the first nodes, and the first node only has a just dot and dot dot, so we returned, and we are returning here from recursive directory as just 1. Okay, that's fine, that's valid. And then after recursion, the current length is still 1. Okay. Okay, so now we try to explore the second node, which is 13. 13, and then what we have? I guess 13 is a symlink, so there's nothing to explore. So our entire recursion stops here, and we have the 2 directories printed. So for just for 2 iterations, it's working. So now let's maybe increase the iteration to 6 and see what's breaking. Let's also increment it here as 6, because with 2 we only had 2 directories to explore, and both directories did not have anything, because last and found just has dot and dot dot, and for bin it's a symlink, so there's nothing to explore there. So now we just incremented the parse nodes to 6. So let's see what's inside there. Hi. Yeah. So if we run it, up to 6 nodes, it is 1, 2, and we have 1, 6. We can explore up to 6 nodes. And I guess this bin boot actually had this extra nodes. Okay, let's just go through it again. We start from the same raw bytes. We print up to 1, 2, 3, 4, 5, 6. Okay, we have print up to 6 directories, and then we try to explore the first directory, which is 11, and 11 is just going to have just 2, 1 and 1, and it has to return recursive directory as 1. That is fine. And then we try to explore 13. 13 is a symlink, so it should not have anything. And where is the return recursive log message? Okay, here we have an issue because at this point calling recursive current length is 3. How is that possible? Because there's nothing to explore in that directory. We only had 2 directories. Okay, maybe this is the issue. So we had 6 directories, and then we started exploring the first directory. We had 2 directories within it, which is just dot and dot dot. I know we have a condition to skip dot and dot dot because those 2 entries are just pointing to the same directory. So we don't have to explore them at all. Okay, so we have this condition here. So if it is less than 1, that is just these 2 entries. To skip those 2 entries, we always set those nodes to 0. Okay, that's fine. And we increment the pass nodes and we return the directories. So that means those 2 actual entries will have a value which is 0. Okay. And I always skip those entries. And skipping is not should not cost me anything because that's just continuous statement. And then I explore up to 6 nodes. I'm allocating size for directory, and what is a directory? It's a pointer to. Okay, it's an array of pointers. Okay, that should be fine. Maybe instead of doing this, I can do one thing. Just put UN64T. So I can have up to 128 directory. And I'm casting the raw bytes plus current. And where do I store it? It's 0, or I'm storing the actual nodes. and this current node would be an extend 4, so I have to convert that into event 64. Okay, now we have parsed nodes, and here once I have the directories, I cannot simply, okay, I can simply just take it, and here I'm just supposed to just cast it as extend directory node. Okay, let's see if it helps. And the current length is 3 here. Current length is 1, and that means it considered these two entries as valid entries. If that's the case, then these two entries should have also been considered as valid entries. There's no way all of a sudden that alone got. Let's do one thing. Let's also print the node that we are incrementing for. So it's going to have a name. It's just yes, and it's going to take temp and just name and temp. Inodes. Inodes. Yes. Okay. Now let's see. This should help a little bit at least. Okay, we are here, the initial loop, and then we don't increment anything. Probably this is where we are supposed to increment, because the current directory count is 1 now. No, then we missed something. Fuck it. Let's just copy this. Okay, we'll copy that, and let's just say all this. Shit it. Paste it here. Okay, we have the 0th node, which is the last and found, and the inode is 11. That's when we incremented it once. And then after we explored that node, it had dot and dot dots. we have the second increment, which is wait, in the last iteration it was 0 and it is incremented to 1. So in this iteration we should see 1. So it is fine. It is bin and 13. Okay, that's fine. It's bin and 13, and we are trying to explore 13. I believe it's just an symlink, so we don't have anything there. And then again we have 2 nodes, and the current directory count is 3. It should be just 2. What the fuck? Okay, it is fine because the next one is boot. Lost and found. And then it's 4, which is null nodes. And then it's 5, which is 0. And it's 6, and it's 7. And overall we have 3, 6, and 7, which is 8 index. And now let's increment it. Let's increment it to 12. Let's increment this to 12. And also do the same with here. Where's that? Let's see. Not this. We also have to increment. Somewhere we had 6. 6. Okay, let's just search for this time. Oh shit. And then lots of random stuff. Oh my fucking god. I'm pretty sure it was just 6. Yeah, it's here. So let's change that to 12. Okay. Now let's see. And okay. We parse 30. Do we have 31? 3, 6, 9, 12, 15, 15 and 18, 21, 24, 27. Okay, we do have it. So is it working? Did we get it working? But how? We didn't really change anything. Who's Terry Davis? I have no idea why it worked because I didn't change anything. I just added some extra logs to confirm what exactly are we incrementing, what's the name of that node, and what's the inode value. Okay, what if we increment it up to 24? Okay, if we do that, we are stuck somewhere, so probably it's a different issue, but at least let's see if we have. Looks like we do have all the values incrementally. So let's try 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We do have all entries. It's working. So now we just have to figure out this issue. What's this indexing within relative? Okay, we can figure that out. But at least we have moved a little bit. We are able to store things, and I have no idea what we changed, because only thing we have changed is that, oh yes, we did change one thing. There's the initial issue was that we were not able to pass down the proper index through the recursion, so we were not able to properly get any data. So what I did is just change that into a global variable, and that way no matter where we are, we just have one variable, and because there's no threads here, and recursion is also in a way just synchronous code, I cannot increment it twice. It should be always be done once, and I am not storing anything. It's just an index, and it can always be incremented, and there's only one place where it is incremented. There's no other place, and it's always incremented right after I initialize that index. So I initialize that index with a directory and I increment it, and it's working. So we found a fucking loophole through our recursion. Okay, that's fine. So now what are we supposed to do? This code will be an issue if there is two people calling the same fucking, if two people call the same recursive directory passing, then that would be an issue because we have one global variable. So we can definitely change this into a heap allocated variable and still use it. That way it will be a value by reference. Yeah, okay, yes, I guess we can get it working that way. But the actual issue was this. It's just that we were not able to propagate the variable properly between the recursion, and the fix is just to add a global variable and increment the total things, and it just works. Okay, kernel is just an interface, because if you don't have a kernel, you'll have to program everything on your own. And that is a good thing for certain interfaces, because if you are actually writing code for some microcontroller, probably you won't have any kernel, because also kernel is just a way abstraction layer, because you don't always want to write an entire implementation to just read a file. You just simply want to call a function called open with a file name, and you should get the bytes out of it. And kernel gives you that functionality, because internally kernel is going to talk to the actual device, actual physical device, and get the bytes for you, and you don't have to do it every time. And then in general it gives you similar extra features around multiple devices, and then also it gives you multiple user interface, also multiple user support. So yeah, I guess kernel is just a way to abstract hardware from software with a common interface, and that's the Linux ABI. And I would say Linux is the most popular API, and I am also trying to follow the same API. I guess that is what kernel is. Okay guys, in general we were able to make a little bit of progress today. We just managed to get the indexing issue done. Let's write a to-do to change this global variable into bucket address and pass it down to every iteration, and just dereference and increment. That way we can have the same functionality. Okay. Yes, that should be it. I'll see you tomorrow, guys. I'll try to implement the same thing tomorrow, and then we can actually debug the second issue that somehow we are running out of something, because it's just stuck here after, let's say, 45 nodes, which is not right, because we should be at least be able to manage, at least be able to write up to 256 directories. Okay, thank you guys. I'll see you tomorrow then.